Welcome back to the e-learning Core 3, Fixed Income Analysis, Session 3.3. In this session, an introduction to passive bond management will be given. Passive managers take bond prices as fairly set and seek to control only the risk of their fixed income portfolio. In the fixed income market, two broad classes of passive management are pursued. Indexing strategies attempt to replicate the performance of a given bond index, while immunization strategies seek to establish a virtually zero risk profile, in which interest rate movements have no impact on the value of the firm. In this session, we focus on immunization strategies and don't look at bond index funds. The basic learning goal is to understand what immunization strategies are and how they can be implemented by financial institutions. However, before we start looking into immunization strategies, let's think about how to compute the duration of a bond portfolio. This is pretty straightforward, since the duration of a portfolio can be computed by weighting the duration of each individual bond by its value relative to the value of the portfolio. To be more specific, let VI denote the value of bond holdings of bond I and DI the corresponding duration of that bond. The value of all bonds in the portfolio is denoted as VP. As mentioned before, the duration of a bond portfolio is then simply the weighted average of all bond durations in the portfolio. Let's have a look at the following example. Suppose a portfolio consists of two bonds. Bond 1 has a duration D1 of 9 years and a value V1 of $1,100. The second bond, Bond 2, has a duration D2 of 2 years and a value V2 of $200. Applying the formula from above to these numbers implies that the bond portfolio has a duration of 7.923 years. The basic idea of an immunization strategy is to control the interest rate risk in bond portfolios. Such immunization techniques are widely used in the financial industry by pension funds, banks, and insurance companies. The reason why these institutions follow such a strategy is that they have a natural mismatch between asset and liability maturity structures. For instance, a pension fund might have a mismatch between the interest rate sensitivity of the asset held in the fund and the present value of its liabilities, which is the promise to make payments to retirees. The interest rate exposure of assets and liability is then matched by matching the duration of the assets and liabilities in the portfolio. Let's have a look at a concrete example of an immunization strategy by considering an insurance company. Suppose the insurance company issues a guaranteed investment contract, GIC, for $10,000. You can think of a GIC as a zero coupon bond that is issued by the insurance company to its customers. Let's assume the GIC has a 5-year maturity and the guaranteed interest rate of 8%. This implies the insurance company has made a promise to pay $14,693.28 in 5 years. Now suppose the insurance company chooses to fund its obligation with $10,000 of 8% annual coupon bonds selling at par value with 6 years to maturity. Verify for yourself that the duration of the bond is 5 years and is equal to the duration of the GIC. As long as the market interest rate stays at 8%, the company has fully funded the obligation as the present value of the obligation exactly equals the value of the bonds. This can be easily seen from panel A on the table on the left. Over the 5-year period, year-end coupon income of $800 is reinvested at the prevailing 8% market interest rate. At the end of the 5 years, the bond has a maturity of 1 year and can be sold for $10,000. The total income after 5 years from reinvested coupons and the sale of the bond is precisely $14,693.28. However, if interest rates change, two offsetting influences will affect the ability of the fund to grow to the targeted value of $14,693.28. A rise in interest rates implies a capital loss due to the fact that the bond will be worth less in 5 years if interest rates had remained at 8%. However, at the higher interest rate, reinvested coupons will grow at the rate faster, offsetting the capital loss. In other words, fixed income investors face two offsetting types of interest rate risk, namely price risk and reinvestment risk. For an investment horizon equal to the portfolio's duration, price and reinvestment risk are precisely offsetting. This can be seen from panel B and panel C in the table, where interest rates once decreased by 1% and once increased by 1%. Since in our example, the duration of the 6-year maturity bond used to fund the GIC is just about 5 years, it matches the duration of the GIC. In other words, assets and liabilities have equal duration, which implies the insurance company should be immunized against interest rate fluctuations. In the example before, we have seen that the coupon bond fully funds the obligation at an interest rate of 8%. Moreover, the present value curves are tangent at 8%, so the obligation will remain fully funded even if rates change by a small amount. However, for greater changes in the interest rate, the present value curves diverge. This reflects the fact that the fund actually shows a small surplus when interest rates diverge from market interest rates other than 8%. This can be seen in panel B and C in the table on the previous slide. The reason for this surplus is due to convexity. Note that the coupon bond has a greater convexity than the obligation it funds. Hence, when rates move substantially, the bond value exceeds the present value of the obligation by a noticeable amount. An implication of this observation is that as interest rates and asset duration changes, the bond portfolio manager has to rebalance the portfolio to realign its duration with the duration of the obligation. Even if interest rates remain constant, asset durations will change simply by the fact of passage of time. This means as time passes, the duration of the asset and liability will fall at different rates. If bond portfolios are not accordingly rebalanced, the durations will become unmatched. In this context, immunization is a passive strategy only in the sense that it does not involve attempts to identify undervalued securities, but requires bond portfolio managers to actively update and monitor the respective bond portfolio positions. Let's illustrate how an immunized portfolio can be constructed by means of an example. Suppose an insurance company must make a payment of $19,487 in 7 years. The market interest rate is 10%, which corresponds to a present value of $10,000 today. The company's portfolio manager wishes to fund the obligation using 3-year zero-coupon bonds and perpetuities paying annual coupons. The question is now how the manager can immunize the obligation against interest rate changes. As explained before, immunization requires that the duration of the portfolio of assets equals the duration of the liabilities. In order to achieve this goal, we proceed in 4 steps. In step 1, we have to calculate the duration of the liability. In our example, the duration of the liability is very easily to compute. It is simply the duration of a single payment obligation, comparable to a zero-coupon bond, and thus the duration equals 7 years. In a second step, we calculate the duration of the asset portfolio. For that purpose, recall that the duration of a bond portfolio is the weighted average of the duration of each bond in the portfolios, where the weights are proportional to the funds placed in each bond. In this example, the duration of a zero-coupon bond is 3 years, and the duration of a perpetual bond is obtained as 1 plus yield to maturity divided by the yield to maturity. If the market interest rate is 10%, we obtain a duration of 11 years. The third step involves finding the asset mix that sets the duration of the bond portfolio used to finance the obligation equal to the 7-year duration of the liability. This implies we have to solve for W, which corresponds to the fraction invested in the zero coupon bond. Doing the computation implies that the weight of the zero coupon bond is equal to 0.5. In a final step, the liability has to be funded. As we know, the obligation has a present value of $10,000 and the fund will be equally invested in the zero coupon bond and the perpetuity. This means for the bond manager that she has to purchase $5,000 of the zero coupon bond and $5,000 of the perpetuity. However, even the position is immunized, the portfolio manager can't rest. This is due to the fact that there is a need for rebalancing the portfolio in response to changes in interest rates as well as the passage of time, which both affect duration. We will see what this means in the context of this example in a second. Suppose now 1 year has passed and the interest rate remains at 10%. The portfolio manager has now to re-examine her position by verifying if the position is fully funded and immunized, and to decide what actions are required to take to keep it that way. In terms of examining the funding of the position, the portfolio manager will recognize that the obligation has grown by 10% to $11,000, as it is 1 year closer to maturity. The manager's fund have grown as well to $11,000. This is because the zero coupon bond have gained in value from $5,000 to $5,500, while the perpetuity has paid its annual coupon of $500 and remains worth $5,000. This shows that the obligation is still fully funded. The second aspect to consider in this process is related to immunization. Here the portfolio manager recognizes that the portfolio weights must be changed. Due to passage of time, the zero coupon bond has a duration of 2 years, while the duration of a perpetual bond remains at 11 years. In terms of the liability, the remaining maturity is 6 years. The portfolio weights must now satisfy the following equation, and solving for W implies a portfolio weight of the zero coupon bond of 0.5555. To rebalance the portfolio and maintain the duration match, the portfolio manager must now invest $6,111.11 in the zero coupon bond. In order to do so, she invests the coupon payment from the perpetual bond in the zero, with an additional $111.11 of the perpetuity sold and invested in the zero coupon bond. After this rebalancing took place, the portfolio is again immunized against interest rate changes. After having carefully studied session 3.3, please start with the review question.